6.7 Operations with vectors in R3. Now, vectors in R3 is just an extension from vectors in R2 with just an addition of a Z component. So let's say we have a point P here, and the position vector of OP will be A, B, and C. So if you want to draw a prism using just that position vector, well, we can know that the point that is always on the Z-axis will be 0, 0, and the Z component. The point on the Y-axis will have 0 with the Y coordinate and 0, and the point on the X-axis will have the X coordinate with 0, 0. So these are the points on the axis. Now, what if how about the points that are not on the axis? So for example, OD will be a point on the XY plane because we have coordinates for X and Y. How about OE? OE will be a coordinate on the XZ plane. And the same goes for OF. OF will have a point on the YZ plane. So we can say that vector OP will just have coordinates A, B, and C. Or of course we can write them in the standard basis vectors, which is A vector I, B vector J, and C vector K. And same as in R2, we can also find the magnitude of vectors in R3 by using the square root and the sum of A squared plus B squared and C squared. But keep in mind, to use this formula, we must first ensure that the vector is a position vector. Now, what if the vector is not a position vector? So assume that point A is a point in R3 and point B is another point in R3. And to find from vector A to find vector AB, we must subtract point B, the coordinates of point B with coordinates of point A. Now, if you can remember, the order is very important. We must first subtract the second point to the first point. And after we subtract, then only we can plug it into the formula to find the magnitude of the vector. Now, adding vectors, they are exactly the same as how we did it in vectors in R2. All we just have to do is add both the X coordinates, Y coordinates, and now the Z coordinates. Now let's move on to a question. If we have point A and point B, let us find vector AB and the magnitude of vector AB. So we know that to find vector AB, all we have to do is subtract point B with point A. So we'll have -1 minus 3, 0 minus 6, and 5 minus 1, which we will get an answer of -4, -6, and 6. So this is our position vector now. Now we can, to find its magnitude, all we just have to do is find the square root of all of its coordinates squared, the sum of all of its coordinates squared. So it will be -4 squared, -6 squared, and 6 squared. So we will get an answer of root 88, or we can further simplify it to become 2 multiplied by root 22. Now, an extra question here, what if they ask for its unit vector? Well, the unit vector, if you can recall, will just be 1 divided by the magnitude multiplied by the vector. So of course you can leave it in this form, or you can just further multiply in together to get the coordinate of this. And 6 divided by 2, root 22. Now we can further simplify it by dividing it by 2 from the denominator. So 3, 2. So we can get a final answer of 2 over root 22, -3 over root 22, and 3 over root 22. And that's it. Thank you for watching 6.7.